Okay, in this example we have another deck of cards problem here. I have letters A and B. I don't have much room here, but I'm going to do my best. Letter A says one card is selected from a deck of cards. What is the probability of selecting an ace or a face card? First thing you have to do here is determine if these two events are mutually exclusive or inclusive, because depending on that, we will use our corresponding formula for probability. So let's see, an ace card or a face card. Okay, if I select an ace card, that would be one of these here. If I select a face card, that would be one of these 12 over here. Now, are these events mutually exclusive or inclusive? Mutually exclusive means, can they happen both at once? Can I select a card and have it be a face card and an ace? No, there's no way. It's either an ace or a face card. It can't be both. So letter A is mutually exclusive events. That means I add probability of A and the probability of B, and that's it. So let's calculate. What is the probability of A for letter A? Probability of it being an ace card is 1, 2, 3, 4 cards out of 52. The probability of it being a face card is 12 out of 52. So the probability of A or B is equal to 4 out of 52 plus 12 out of 52, which is 16 out of 52. And you can reduce this or use your calculator to find the decimal approximation. Okay, and I'll leave that up to you. Letter B, one card is selected from a deck of cards. What is the probability of selecting a 3 or a heart? Now let's look at these two events. Can these events happen together at once, or are they mutually exclusive? Let's see. If I select a 3, that would mean I'd select any one of these 3s, right? Any of these 4 3s, or a heart. A heart would be any one of these 13 cards here. So notice that I can have an event where I choose a card randomly, and the card that I choose, it can be a 3 of hearts. That means that event A and event B can both happen together at once in this example for card number 3 of hearts. So this, these two events, selecting a 3 or heart, are inclusive. That means they happen together. So for this probability, I have to look for the probability of A, and event A is selecting a 3, and that can happen 4 ways. The probability of B selecting a heart, that is 13 hearts out of 52, right? I have 13 hearts, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 hearts. And so the probability of A or B has to be equal to the probability of A, which is 4 out of 52, plus the probability of B, which is 13 out of 52. But notice that I have to subtract the quantities that I'm counting twice. And which one is that? Let's draw it here. Let's encircle all the 3 cards. Here are all the 3 cards. That's 4 of them. And if I encircle all of the hearts, here are all the hearts. And notice how I have a card that belongs to both groups. This is the intersection of both groups. One card intersects both groups, so I counted this card already when I counted my 3s. I counted 4 out of 52. So I have to subtract that card from my second probability, which I counted again. Okay, 1 out of 52. So that would be equal to 16 out of 52. And you can verify that by counting just the total of your cards. If I change colors here, let's change to blue, just so that I can show you what this group of cards looks like. This would be my group of cards. This blue, I'm sorry about, here it is. Okay, so when we count that group, I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 out of 52, and that's what we calculated. Okay, now you can reduce this fraction or turn it into a decimal approximation and multiply by 100 to get the percentage of probability. Let's do another example.